In today's class, we are going to discuss the topic matrices and determinants for the entrance examinations, that is JEE as well as for CET purpose. We are discussing the questions. So before discussing the questions, we should know the synopsis. So synopsis means just I am going to give you a brief introduction about this topic. So what are the formulas we should know and what are the definitions, that is terms we should know, that I am going to discuss in this class. So what is that? That is nothing but synopsis, that we can call it as synopsis. So already we discussed the definition of the matrix and what is the difference between matrix and matrices. Clear? So matrix is a singular and matrices is the plural form. Clear? So and also we discussed the difference between the matrix and determinants. That all we discussed, but just I'll recall that all things, my dear students. Clear? And please remember, in your JEE examinations, from this topic minimum we will get 2 questions. Minimum I am telling. So minimum will get 2 questions. So around here it is 8 to 15 marks you may get in your examinations. Clear? So just we'll recall now. So matrix. So my dear students, matrix means what? Matrix means it is arrangement of an rectangular array of numbers or functions. That we can call it as, generally we can understand the matrix means like. Clear? And also we have another one definition, that is a set of mn numbers. A set of mn numbers, it may be real or imaginary, arranged in the form of a rectangular array. Clear? Array means that is nothing but arrangement. So the mn elements, if we arranged in the rectangular arrangement in the rectangular form, if we write, means that we can call it as that is nothing but a matrix. Please, my dear students, please remember, if you wanted more information, means please go through this topic that already discussed for the board examinations. In that topic in detail I discussed. Here just I am recalling the things. Clear? So here it is. What is that matrix? A set of mn numbers arranged in the form of a rectangular array, where we are writing all the any numbers or functions, any trigonometric functions we may take, or any imaginary number, if you write in the rectangular form, that is nothing but some rows or some columns, if we write, means that we can call it as a matrix, my dear students. Clear? So here it is. Also we know that where m means what m denotes. M denotes rows and n denotes columns. We will write the matrix or the order of the matrix. What is the order of the matrix? The order of the matrix is nothing but how many rows and how many columns are there, that we are writing in the form of rows into column, or we will write it as rows by column. The notation is like this, m cross n. So this m cross n will gives us the order of the matrix. So order of the matrix means what? How many rows are there and how many columns are there, that we should count, and then we should write in the form of row by column, row into column. Like this if we write, means that is nothing but the order of the, here it is, given matrix. Clear? And read it as m by n. So remember, always m is nothing but rows and n is nothing but columns. And always we will write in the form of rows first and then column. Rows by column we will write. So I think everyone know, but still I'll just remember, rows means this we can call it as rows and this we can call it as columns. Clear? So the horizontal, here it is, the horizontal line indicates, corresponds, the horizontal line indicates the rows and the vertical lines indicates the columns of the matrix. So in general we will write the matrix, we will write inside the bracket, that is we will write the matrix of the order m cross n, like this. The first element a11, a12 up to so on a1n. So here it is like this, a21, a22 up to so on a2n. So here it is am1, last here it is up to so on am1, am2 up to so on amn. It means how many rows are there? Here m rows are there. So m denotes the rows and n denotes the columns. It means in this matrix we have m rows and n columns. Clear? And my dear students, please remember, we will write the matrix, the element a11 means what it indicates, the element a11 means that is nothing but this is first A11, A subscript 11 means what it indicates? It indicates that this is first row and first column element. First row, first column element we can call, my dear students. Clear? So this is all about A11 means like this. A12 means what? A12 means that is nothing but first row, second column element. So A21 means second row, first column element. So like this we will write. Or we can also denote it as A is equals to Aij. What is Aij? Aij is nothing but this is also matrix. If we write like this, this will be lengthier. So in short, what we can write? In short, we can write it as Aij. And here we will write the order as m cross n. This is also same and this is also same, just the notation is different. So in every case we cannot write all the elements, is it? So therefore we shorten that one and we will write like this, A is equals to Aij. Is it understood? So this is all about, my students, notation. And next we will discuss what is submatrix. So submatrix means what? Submatrix means let A m cross n, subscript it is A m cross n be a matrix obtained by leaving some rows or some columns or both, that we can call it as a submatrix. So submatrix means what? Submatrix means here it is, if you leave this row and this column, whatever remaining is there, so this we can call it as a submatrix. Submatrix means what? A matrix obtained by leaving any row or any column or both, whatever we will get remaining. So this is nothing but submatrix. Clear? This is all about submatrix. And next we will move to the next concept, that is types of matrices. My dear students, here we will discuss one by one. This is first one, we can call it as, this is nothing but first we will discuss it. Here it is, what is matrix, what is the definition of the matrix we discussed, and the notation for the matrix, and what is submatrix. This all comes under the first point we will learn, and second point we will learn it as types of matrices. So in that, the first one I am going to discuss what is meant by row matrix. So the name itself tells you a matrix having only one row. So in which a matrix in which it has only one row, that we can call it as row matrix. So generally we will write here it is first only one row will be there. So therefore order will be 1 cross n. It may be, here it is columns may be, here it is, it may be 10, it may be whatever, n number may be there, but always the row must be 1. So therefore constant it is always, so therefore the order will be 1 cross 1. You can take like this. So here it is clearly, in particular if you want to example means you can write 1, 2, 3. So this is example for the, here it is example for the row matrix. And what is the order here? So order of the matrix is nothing but one row is there and how many columns? 1, 2, 3. So 1 cross 3. 1 cross 3 is the order of this matrix. Clear? And next second one, my dear students, a matrix having only one column. A matrix having only one column is called as a column matrix. So here it is column matrix having only one column, means one column must be there. There is no matter of the, here it is rows. It may be, here it is m number of rows. Clear? It doesn't matter to us. A matrix, just a matrix is said to be column matrix if it has only one column. So this is example for the column matrix. So here it is, that's why here it is only one column will be there. Here one is column numbers will be constant, that is 1, and the row will be m. Clear? So in particular again if you want example means you can write here it is, the example I can write here it is as 1, 2, 3. So this is example for the column matrix because only one column is there. What is the order of this matrix, my dear students? The order of this matrix is 1, 2, 3. 3 rows are there, 1 column is there. So therefore this is the order of this matrix. Clear? And next, square matrix. So what is square matrix? Square matrix means a matrix in which m is equals to n. What is m and n? M is nothing but rows and n is nothing but columns. So a matrix in which number of rows is equals to number of columns, then we can say that such a matrix is a square matrix. So example for this one you can take here it is, example for this one is, here it is 1, 2, 3, 4. My dear students, first of all, tell me the order of this matrix. So the order of this matrix is 1, 2. 2 rows are there, 2 columns are there. The order of the matrix is 2 cross 2. So my dear students, this is the number of rows is equals to number of columns. Number of rows is 2, number of columns is equals to 2. So therefore order of this matrix is 2 cross 2. And please remember, any square matrix can be say it is order nothing but here it is 2 cross 2 is there. Instead of saying 2 cross 2, just we will say that this is a square matrix of order 2. Order of 2. This is the here it is square matrix. For the square matrix, always m is equals to n will be there. So instead of saying m cross n, just we will say it is the order of n, or you can say order of m, because m is equals to n. So in generally for the square matrix, a matrix of order n we will say, my dear students, for the square matrix. Understood? And next, my dear students, what is diagonal elements? I am not discussing about the diagonal matrix, that we will discuss later. Diagonal elements means what? Diagonal elements means elements aij where I is equals to j in any matrix. In any matrix, if this subscript is same, then we can say that that are the diagonal matrix. Say for example, my dear students, I'll take the example so that you can easily understand. First of all, I'll take the example. In that we can understand what are the diagonal elements. Say for example, here I'll take the example here. So here it is A is equals to any matrix. Consider as of now I am considering one matrix 1 2 3 4 5 6 7 8 9. My dear students, remember, so this is nothing but this element is A11 element, this is nothing but A12 element, this is nothing but A13 element. Clear? Here it is, this is A11 position element. It means first row first element is 1, that we can generally we can denote it as A11. This is A12 first row second element, first row third element, that we can write it as A13. Similarly this we can write it as A21, A22, A23. This we can write it as A31, A32, A33 element, because third row third element, third row second element, like this we will write, my dear students. Clear? So in this what it says that the elements aij where I is equals to j. I is equals to j means what? This both should be same. It means here also one, here also one. A11, A22, A33, all these we can call it as diagonal elements. Why it is diagonal elements? Because the subscript both are same. I throw j com erdu I and j, both I and j values are same. Clear? So aij is equals to aij. What they told? Aij where I must be equals to j, means row and column should be same. A11 means first row first column, both are same. A22 second row second column, third row third column. Clear? So therefore this we can call it as here it is diagonal elements. Clear? So this is all about diagonal elements, this one. Next we will discuss what is diagonal matrix. So diagonal matrix means what? Diagonal matrix means a square matrix such that aij is equals to 0 for every I not equals to j. For every I not equals to j means, my dear students, please remember, in this diagonal elements, always in the diagonal elements A11, A22, A33, all these elements are rows and columns are equal. But remaining all cases, here it is A12. A12 means I is not equal to j. These two values are not equal. These two values are not equal. Here 2, 1 not equal. So except these diagonal elements, remaining all elements are aij elements where here it is I is not, here it is I is not equals to j. I is not equals to j means above the diagonal elements, below the diagonal elements must be 0. Then such a matrix we can call it as a diagonal matrix. So example, you can take the diagonal matrix. Example for the diagonal matrix, we can take it as, here it is A is equals to, here we will take a square matrix such that aij 1 0 0 2, here it is 0 0 0 4. So this is example for the diagonal matrix. Why it is example for the diagonal matrix? You can observe, my dear students, a square matrix such that aij must be equals to 0. Aij equals to 0 for every I should not equals to j. I should not equals to j means only in this case these are the elements where aij elements where I is equals to j. Only this case I is equals to j. Remaining all cases I is not equals to j, my dear students. So therefore those all elements are 0 0, here it is. So therefore this is the diagonal matrix. So you can remember like this. Now in notation form you can write like this, or definition means what you can say? You can say that a matrix in which all the non-diagonal elements must be 0. A square matrix in which all the non-diagonal elements must be 0, then such a matrix we can call it as a diagonal matrix. Clear? So this is example for the diagonal matrix. And next, my dear students, scalar matrix. So what is mean by scalar matrix? Scalar matrix means a matrix in which aij equals to 0 for every I not equals to j. Aij equals to 0. Aij elements for all I not equals to j. I not equals to j means what you should understood? I not equals to j means these are the elements which are non-diagonal. Clear? So in the non-diagonal elements, non-diagonal aij is equals to 0 for every I not equals to j means this is nothing but non-diagonal elements. So non-diagonal elements must be 0. Non-diagonal elements must be 0 and aii equals to k. K is any constant which is not equals to 0. So diagonal element, it may be any non-zero constant number, but diagonal elements, here it is, non-diagonal elements must be 0 and diagonal elements it may be any constant. So that is what we can call it as scalar matrix. So example for the scalar matrix now I am going to write. So example for this scalar matrix is, here you can take, my dear students, I'll write it as, here it is, aij equals to 0. Here it is non-diagonal elements. So I'll write non-diagonal elements must be 0. So 2 0 0 0 2 0 0 0 2. So this is the scalar matrix. Why it is scalar matrix? This is scalar matrix because all non-diagonal elements means this above this diagonal and below this diagonal, all non-diagonal elements are 0 and the diagonal element is constant, that is aii is equals to k. So therefore this is example for the scalar matrix. Clear? So my dear students, please remember all this information we learned in the earlier classes, but still I am revising the things. Synopsis, as a synopsis I am discussing. Clear? So in detail if you want means you can refer my video, there I discuss in detail for the board examination purpose. So there you can if you watch that video means you can clearly understand. Here just I am recalling the things. Clear? So still if you have any doubts you can come at me, I'll reply for that. So up to here please pause the video and write it. Please pause the video, participants, until if you have here up to here if you have any doubts please write down, and the remaining types we will discuss in the next video. Thank you.